It's America's longest running talk show on computers. It's Computer America, bringing you the biggest names in technology with guest interviews, new products, and your emails. Listen live at computeramerica.com on any device around the world. Email the show at live@computeramerica.com or find us on social media. Be sure to check out our website for contests, giveaways, show notes, live video stream, podcasts, and more. You're listening to Computer America.
Hello and welcome everyone into the Computer America Show. We are the nation's longest running, nationally syndicated radio talk show on computers and technology. And everyone, welcome to the program. I hope that you're doing well and you are ready for the show today. Because, yep, you guessed it, on the show every Friday we have the one, the only Mr. Ralph Bond. And with him, he is our science and tech trends correspondent, and we cover a number of stories, that number being 4, and they're always a lot of fun. They're always good-natured, not a lot of, not too many killer robots, but hey, you're going to have to find out today. So, ladies and gentlemen, computeramerica.com. That's where you'll find everything, including past shows, future shows, show notes, articles, reviews, topics, video, obviously the podcast or wherever podcasts are found. And with that being said, links to all social media. So I hope that everyone out there is having a great week and they're ready to do something fun. I know that Labor Day was, kind of made this a short week, but either way, we're back at it. And ladies and gentlemen, let's go ahead and bring Ralph on. So, as I said before, he's a longtime Computer America contributor and, of course, our science and tech trends correspondent. You can find more at his website or at our website. We have a section totally dedicated to him. Ralph, welcome back onto the program. How you been?
It's great to be back, Ben, and to pick up on what you were saying a moment ago. You've come to the right place if you want uplifting and inspiring stories about science and technology. They're going to take us to better and happier places with a minimum amount of killer robots, okay?
We're going to do our best.
What we're going to do, that's it. We talk about things in robotics, medical technology, sustainable energy technology, transportation advances, space research, physics, you name it. Everything is available, but it's usually stuff you don't hear about in the mainstream news. Sometimes it is, but most of the time, the stuff Ben and I share with you on Fridays is not something you're going to hear maybe anywhere else necessarily. We give you in the show notes. Come out to computeramerica.com. The show notes will have links, pictures, everything has been said. You can dive deeper into any of these stories you want to, because what we do is just give you the highlights, not the total depth of the story. So lots of fun stuff today, starting off with NASA.
Absolutely, NASA never disappoints, and this one I actually did catch. So hopefully some other people did out there as well, but I didn't really dive into the specifics of it. The images look cool, but I guess the implications of what it is are going to be very, very far-reaching and hopefully very helpful in the future. So yeah, let's talk about pollution.
Yes. So on August the 24th, just recently here, NASA revealed the first images of U.S. air quality and pollution generated by its pioneering air pollution sensor. And this comes from a fun website called wonderfulengineering.com, a story by Jannat and Nisa. Hope I'm saying that right. We also have a link to NASA's own website and a link specifically to this new technology's website as well. So all three of those links are in the show notes for you. And here we go. On August 24, NASA's pioneering air pollution sensor, it's called the Tropospheric Emissions Monitoring of Pollution, and let's just go with the acronym as they do, TEMPO, unveiled its first images illuminating the dynamic fluctuations of toxic pollutants across the United States. So it's positioned within the geostationary orbit atop the Intelsat 40E satellite. TEMPO's operational vantage point resides at 22,000 miles above the Earth's surface. And now TEMPO is measuring hourly daytime air pollution over greater North America. And there's some great images in the show notes and, of course, on the links that I just gave you. And these revealing images taken during the testing phase from July 31 through August the 2nd document the fluctuating concentrations of nitrogen oxide, which is a harmful byproduct of fossil fuel combustion across major North American cities. And, a little side note here for a second, Ben. you and I and many of all of us, of course, are always talking about carbon dioxide. Carbon dioxide, this is the terrible villain of climate change. Nitrogen oxide's not great either. So
there's a lot of gases out there that are just as bad or a lot worse than carbon dioxide. It's just, I guess, for people to kind of understand climate change to begin with, like you breathe in and then you breathe out. That's like an easy way to kind of understand what a greenhouse gas is, the stuff that you exhale. So, but yeah, there's definitely stuff a lot worse and that we definitely need to keep a close eye on.
Yeah, exactly. So why would NASA be so interested in nitrogen oxide? Well, of course, there's basic reasons why. We were just alluding to that. But here's something interesting from the article. It says, with the potential to inflict respiratory harm and contribute to asthma. Now, there's a lot of the population for which this applies. Nitrogen oxide warrants meticulous observation to safeguard public health. So that's the motivation. And once again, too, you think of NASA, you just think of rocket launches and big space program go to the moon. NASA's doing all kinds of stuff across the board. It isn't just the exciting stuff like the Artemis project to go to the moon or whatever. So kind of an interesting example of NASA's range of activities. But going on with the story here, Tempo's observational prowess hinges on its capacity to measure the sunlight reflected off the Earth's surface, atmosphere, and clouds. And by analyzing the distinctive wavelengths of absorbed light, Tempo deciphers the composition of the air and quantifies the concentrations of various chemical constituents. Yeah, that's interesting. The whole bit about analyzing the sunlight. And this precision empowers scientists to glean invaluable insights into complex interplay of pollutants and atmospheric elements. And how did it happen? It was launched aboard a SpaceX Falcon 9 rocket in April. Tempo underwent meticulous positioning to align it with its intended trajectory. That's another thing you don't think about. You launch satellites just up there. No, they've got to adjust it, fine-tune this thing.
Yep.
So right now, it's operational and validated. Tempo is the premier satellite to furnish real-time, that's the key, real-time air pollution measurements across North America. So again, if you're an asthma sufferer or you care about climate change and how we're going to be able to monitor things and so forth, this is a great story to check out and learn more about.
Yeah, and I'm very curious if they're going to be able to use this data to, and obviously the first website that you linked to has a picture of Los Angeles and New York City. You can imagine that those two are going to be pretty severe in the pollution category. I'm curious if they're going to be able to, have enough detail in the images to kind of say, it increases during this period, or in the past 3 months, we've seen an increase here. What has caused this? Like, you really can't do anything, and this is a big thing, especially with governments. You can't do anything until you measure it. You don't know if it's increasing. Right. You can't tell if it's decreasing. If you do something, they don't want to do something if they can't say, okay, are we having an impact? Yes or no. So having the data is like the first step to fixing it, or at least making things better. So this is a really great story and really an amazing satellite that NASA put up there.
Yeah, it is a great story. And I think, to your point about measurement and so forth, I'm going to guess that what they're going to be doing is, of course, starting very recently. And now let's imagine we're 5 years, 10 years later, they can see, one of the things they might be able to see is, hey, folks, as we've adopted more non-fossil fuel ways of living, we've seen a decrease. Look, historically, back in 2023, in August, it was here in New York or LA, or you pick your urban area. I mean, and now look, it's gone down.
Yeah, that's actually a really great point, because we're obviously making the big push to electric vehicles and so on and so forth. To like, these are steps that we know that we should be taking, but to be able to quantify it and say, look at this map and look at this map and look how different they are. To actually see that we are making a difference, that an impact is being made, that would just encourage people all the more. So to be able to measure that, very important as well. That's a very good point. Yep. So story number one, and again, the images, are the loudest part of this article. So if you check those out, computeramerica.com. Now, with that being said, story number one, let's go ahead and jump over to story number two, and emphasis on jump, because robots are getting more ligaments. They're getting more appendages. Yeah, robots are getting more complex, and to be able to control those, not the easiest thing in the world. It takes babies years to learn how to do this. So, Ralph, what are these robots up to?
Yeah, this is a great story. So the headline here is Artificial Intelligence Helps Robots Manipulate Objects with Their Whole Bodies. And we'll get into the details here from the article. It's from MIT, good old Massachusetts Institute of Technology News, their outlet. A story by Adam Zewe. And we've got the link and some images and so forth. And I encourage you to use the links and then look at the video that's embedded in the article on the MIT website, because that'll help explain what we're going to talk about. But let's set the stage as they do in their announcement. So imagine you want to carry a large, heavy box up a flight of stairs. You might spread your fingers out and lift that box with both hands, then hold it on top of your forearms and balance it against your chest, using your whole body to manipulate the box. And then you and I would do this just instinctually. We wouldn't really have to think about it. But it turns out, as we'll find out more in the article, in actuality, this is in lightning fast fashion, and based on experience, we humans can do this instinctually in nanoseconds, right? It's not that big of a deal to us. At least we think it isn't, because this whole process is hidden to our consciousness at the time we try to do this, right? So humans are generally good at whole body manipulation of objects and so forth, but robots struggle with this task. To the robot, each spot where the box would touch any point on your fingers, arms, torso represents a contact event that must be reasoned about, or another way of putting it, processing each contact point event. So let that sink in. It's a little bit of an interesting idea. The incredible number of things that go on when you and I just pick up a box and cradle it in our arms and go upstairs. With billions of potential contact events for any such act, like we described as carrying a box, planning for this task quickly becomes very problematic for a robot. Okay, so now what? This is why a lot of the industrial robots are arms that come out and they pick something up and they put it into the car chassis, and that's it. It's relatively straightforward, right? But now MIT researchers have found a way to simplify this process, again, this processing of contact points, known as contact-rich manipulation planning. And they use an artificial intelligence technique called smoothing, which summarizes many contact events into a smaller number of decisions to enable a simple algorithm to quickly identify an effective manipulation plan for the robot. I know that's a lot to sort of drink in here, but we'll get into some more details. And the key to this, Ben, has to do with something called reinforcement learning. All right. And I'm going to give you now a generic definition. So a generic definition of reinforcement learning is a machine learning technique where an agent, like a robot, learns to complete a task through trial and error, just like we do as humans, with a reward for getting closer to the goal. I'm not quite sure if they rewarded the robot at MIT.
I don't know if that's like a Scooby snack or if that's going to be like a high score. Like, I don't know what a robot values as a reward.
Yes, that part I thought was sort of funny. But anyway, researchers say this type of learning takes a black box approach because the system must learn everything about the world through trial and error. And you can imagine this learning about trial and error has to happen incredibly fast.
It's very similar to that's the same kind of technology that AlphaGo a little while ago was able to play Go, which is something that scientists said wasn't going to be possible for a while. Ralph, they essentially put the machine against itself. So instead of having to wait for a human to sit there and play Go with the robot and challenge it, it played with itself 10,000 times a day, 100,000 times a week. They're able to play infinitely more games than a person and be able to learn all by itself. So I guess the same thing, but this time, and by the way, very affectionately it seems, be able to lift Mr. Bucket in the video.
The video is very, very enlightening. And it's just, again, the concept is this act of picking something up or something we take for granted involves millions, if not billions of instantaneous decisions and so forth in a way. And so the whole point of this story is what MIT is saying. Look, we could sit there and chunk through all these possibilities and take days, hours, months to figure out the move? Or can we figure out a way to, using this smoothing technology approach, condense the decisions down to something that can be executed very quickly and open up a whole new world of possibilities for robots? That's
very, very useful for real world applications. Yeah, for sure.
Exactly right. So picking up again on this whole idea of reinforcement learning has been used effectively for contact-rich manipulation planning, which is what we're talking about here, where the robot seeks to learn the best way to move an object in a specific manner. But because there may be billions of potential contact points that a robot must reason about when determining how to use its fingers, hands, arms, and body to interact with an object, this trial and error approach requires a great deal of computation. We certainly can understand that. But even though smoothing, this technique, generally simplifies the decisions, searching through the remaining decisions can still be a difficult problem. So if you condense the possibility of decisions down, you still have a huge process in front of you. So the MIT researchers combined their model with an algorithm that can rapidly and efficiently search through all possible decisions the robot could make. And with this combination, the computation time was cut down to about a minute on a standard laptop. Time out, let that sink in. So this whole process of manipulating an object in a black box learning situation through their algorithms and their combination of approaches and the smoothing and so forth, cut down that time to about a minute. And did they use a giant supercomputer? No, a standard laptop. The implications of this are so wow. Here we go. So while still in its early days, this artificial intelligence-based smoothing method technique could potentially enable factories to use smaller mobile robots that can manipulate objects with their entire arms or bodies rather than large robotic arms that can only grasp using their fingertips, right? And this technique could be useful in robots sent on exploration missions to Mars or other solar system bodies, since they could adapt to the environment quickly using only an onboard modest computer. And of course, the implications for the real world here on Earth are profound. So this is a really interesting robotics story, and hooray again for MIT.
Yeah, no, I really like the fact that they're able to do this with a not as powerful computer. Not saying laptops aren't powerful, but it's not asking for crazy, unobtainable computer, hardware.
Right.
And very, very good point with, maybe on exploration to Mars or other systems and things like that. What is it? I think like real-time communication between Mars and Earth is like 7 minutes or something like that. So it's not like you can say, oh no, avoid that hole. If you're just setting that thing on autopilot, you don't have time to, kind of wait those couple minutes for the thing to explore. This is what's needed if we're going to have robots in our lives. And Ralph, I don't know if you saw the story earlier this week that Elon Musk, our favorite eccentric billionaire psycho, he's saying that within the next couple of years, how long before you have a robot doing your dishes? And I mean, when you're talking about a robot being able to grab a dish out of the sink, which is pretty delicate, and be able to put it into a container, i.e. the dishwasher, you're going to need these real-time things, because you can't just say, okay, well, everyone has to switch to one kind of dish and they have to orient it in the exact way that the robot's going to, no, it's going to have to be able to handle every kind of dish in everyone's home if it's going to have any hope of being, in our homes. So this is what's needed for, robots in your day-to-day life.
Yeah. Well, and Ben, to pick up on your point, think about all of the areas of life here on Earth. Let's take convalescent homes. Let's take a hospital situation where you have a terrible shortage of nurses or nurses' aides. Let's go down the scale a little bit from a nurse. People that are just going to go in and deal with the bedpans of the disabled elderly. I mean, it's kind of gross, but I mean, there's all these things. So if a robot could be using inexpensive computational hardware with this fantastic software, and yet could go in and on the fly through black box learning, as it were, figure out, Joseph, my patient, has moved over here. I need to pull the sheets this way to help him. And you get the picture. I mean, the implications here are so profound, again, because we're talking about clever software combined with modest computational power in a robot. And the story and the experiments that MIT did, Ben, as you saw, dealt with the torso, arms, fingers, hands, and so forth of the robot. But of course, to your point, it could apply obviously to the legs and feet of the humanoid robot on Mars, encountering a hole and being able to figure out things on its own without having to wait 7 minutes for instructions from Earth. So it's interesting stuff.
It really is, and this is just one technique of many that I'm sure that eventual robots that you might interact with one day will be taking. So this is a step, but still a step that the robot might take by itself. So story number 2. Story number 3, let's go ahead and go on over to Dallas. No, don't panic, everyone. Just for the story. We just have to go to Dallas for the story. Well, and the fear is even more palpable when I say we're going to the Dallas airport. Yes, I know, crazy. Yeah. But this is actually very cool. It's again, and while it's not a physical product, and the last couple of times we've done the show, we've talked about turning waste into something useful. Usually it's like a chemical or a byproduct or concrete or coffee grounds.
Right.
Last week, like we did, Ralph. This one's not so much a physical thing, but it's I guess like a force of wind is a physical thing. But anyways, turning waste into something useful yet again. So story number 3.
Yeah, and before I give the headline, I'll just I don't know how long ago it was, maybe a year ago or more or something. We talked about a fascinating story out of Turkey, Istanbul area, where on their version of a freeway or highway, down the median, they put little columnar turbines.
That's right.
Excuse me. And as cars passed, generating wind, it was constantly spinning these turbines, and they put hundreds of them.
Yeah. I think that was in the bus lanes where you had buses going on either side, and
that sort of thing.
Much taller. And they were able to. Yep, I remember.
It was one of those deals where you go, ding! What a great idea! Taking advantage of this constant wind source and using these compact columnar turbines placed in a place that doesn't bother anybody, doesn't hurt anything, and they're just 24/7 generating electricity. Well, this story is kind of related in a way to that. So here's the headline. Dallas-based JetWind, run those two words together, JetWind Power Corporation, wants to install turbines at airports to collect the powerful wind from jet engines. And this comes from the Dallas Morning News, a story by Kyle Arnold. We've got the links, of course. Also have a link to JetWind's own webpage, which is really good, and a link to a really good in-depth presentation video that they put together to explain this idea. But the thing that's so great about this idea, Ben, it's so simple. It's just like, doink, why didn't I think of this? It's great. Anyway, here's the story. So the Dallas Love Field Airport. We're not talking about the biggest airport in the Dallas area, but the Dallas Love Field Airport, now the busiest medium-sized airport in the United States, is testing JetWind Power Corporation's energy pods, they call them, which use the wind generated by jet engines as they depart gates to spin turbines and make electricity. And if you've got the show notes, folks, if you're listening to us on a podcast, please come out to computeramerica.com, get the show notes so you can see what we're talking about after you get off the freeway or wherever you are. So it's the first full-fledged trial for the Dallas-based technology firm founded by Dallas-based orthopedic surgeon T.O. Sorrell. So an orthopedic surgeon came up
quite
with
the
this
change of jobs.
Yeah, exactly. So it's a fun story how this happened. So JetWind and the Dallas Love Field Management plan to test the 3 turbine pod. It's like a rectangular box with 3 spinning blades during the remainder of 2023 to see if it holds up to the heat, cold, and high winds at the airport. It produces enough power, if it produces enough power and weathers the elements, Mr. Sorrell or Dr. Sorrell thinks it could help power every airport in the country and maybe around the world. So Dr. Sorrell noted, quote, "The idea came to me maybe 15 or 20 years ago when I was flying. We were about to take off, and I looked out the window, and there was stuff flying all over the place. Of course, generated by the wind, if you will, from the jet engines. The jet blast from a commercial airplane can produce hurricane force winds of up to 150 miles per hour as far away as 200 feet away from the engines. 150 miles per hour on average, even if you're 200 feet away from that engine, according to jet manufacturer Boeing. That's a fun little side note here. So putting a wind turbine at an airport seemed like a no-brainer to Dr. Sorrell, but the idea is easier than its execution. For one, airline runways need to be relatively free of debris and obstacles to allow planes to navigate. Well, of course, the devices also need to be able to withstand weather and extreme winds from the jet engines themselves. So back to Love Field in the Dallas area. So at Love Field, the JetWind energy pod is positioned just in front of the wind deflectors, those sort of like solid walls. That's a wind deflector. You'll see that at the airport next time you go. So the energy pod is positioned just in front of the wind deflectors near the airport's air traffic control tower. Batteries that just store the energy are stored in a trailer behind the wind deflector in this experimental installation. That gives the turbines housed in a 6-foot-tall box access to the jet blast from planes pulling out of gates 5, 7, and 9 at the airport. Now, for now, the batteries are used to charge electric vehicles at the at the Federal Aviation Administration Air Traffic Control Tower next to the airport terminal. So it's unclear exactly how much energy the turbine generators will be able to produce. Where it's currently positioned, the energy pod only gets a few dozen jet blasts a day. Remember, this is an experiment. To produce a significant amount of energy, many more will need to be placed all over the airport, which obviously could be done. So Isaac Ellison, Love Field's interim environmental manager, noted, quote, we would want to be the first airport to fully implement a technology like this. So again, a absolutely rock solid, down to earth, simple idea that would take advantage of all of this energy. And here's another thing too, Ben. In the future, we hope to have electric or hydrogen electric combo jet aircraft and so forth, replacing the fossil fuel stuff we have today most of the time. But they're still going to generate that thrust, right? They're still going to generate that wind, if you will. And so this is not an idea that goes away when we convert from fossil fuel. It has legs that'll go on indefinitely into the future. So fun story, I thought.
Yeah, and the website even points out that they have proposals for the military. Yeah. And here, and it kind of makes sense. You know, you have like the aircraft carrier, and instead of like handrails and guardrails for people, you would replace them with these things. To an extent, and on aircraft carriers where power is finite, you'd be able to just throw these wherever the jets are taking on and off on aircraft carriers and get the same effect.
Don't you love it?
Yeah,
Ben, again, thinking about the folks in Turkey and Istanbul, you could put these alongside of busy road situations too. Well, it's so cool.
Yeah, the website even mentions high-speed trains. Trains, of course, going. You could put them along there and get the exact same thing.
Yep.
And I love the thinking, and I'm shocked that I haven't heard more about this, before. It's, again, turning waste, which is wind energy, and, you really don't think that's not much of a waste because, after the wind blows, that's it. That's the end of it, whatever. Right. But to be able to capture that and reuse that, that's something that's a very, very, good idea because, like you said, wind is going to be here regardless of what what we're using to make the wind. So it's very, very cool.
And how about this? Isn't Chicago is a so-called windy city, is it not, I think? Imagine putting these things on top of buildings where you have a very regular source of wind.
Yeah.
Coastal communities often have a lot of wind all the time. So the possibilities here are endless.
I feel like
simple.
There, Ralph, you're kind of getting into just wind turbines, just in general. Same thing. And wind turbines are definitely going to be kind of here, and windmills. not windmills. Wind turbines are going to be here for a long time. It's just, I guess, what this guy innovated on was how compact and small and where they can be positioned.
Yes.
So
and simple. Simple. There's
very,
nothing
very
here
simple
that's like
as
exotic technology at all.
For sure. So there's story number 3. Looks very cool as well. Story number 4. Ralph is very good at finding medical news because, when we think about it, Ralph, unless it's like about Wegovy, you don't really hear much about medical stuff, unless it's a new miracle weight loss injection. You don't really hear much about it, but it turns out a lot of research is happening in the field. So story number 4.
Oh my gosh, yes. Yes, story number 4, as Ben was alluding to, often we end our Friday segments with something in medical technology or research and so forth. And this one is just wonderful. It comes from medgadget.com, a great website, a story by Conn Hastings, and we've done his stories over the years many, many times. Headline, 3D printed heart muscle beats. Subtitle, the ink helps heart muscle cells align so that they can contract in coordination. We'll explain more about this. Again, we have links to this. We also have a link to the documentation from the researchers at Harvard who worked on this research and technology. So that's all in the show notes. Come out to computeramerica.com and get the show notes. And there's a great link to a video, really, really good video. So here we go. Here's the story. Researchers at the Harvard John A. Paulson School of Engineering and Applied Sciences have developed a technique that allows them to 3D print a heart ventricle that can then go on to beat rhythmically. What? 3D print a heart ventricle that can go on to beat rhythmically. Okay, got my attention. The technology could allow researchers to create heart models to test new cardiac drugs that may even pave the way for fully implantable cardiac components. What?
Very cool.
We're on the threshold of maybe being able to 3D print. Oh, this guy needs a new ventricle. Okay. He needs a new valve. Okay. He or she, I should say. Wow. Okay. So the method involves using rotary spinning to create small fibers that are then infused into a printable hydrogel ink. When 3D printed, this ink retains its printed structure, and the cardiomyocytes within it align along the direction of the included fibers. And right away, when I read this the first time, I went, ding, ding, ding. Wait a minute. Don't assume I know what a cardiomyocyte is. Okay. So what are they? From the perspective of cardiology, a cardiomyocyte is the cell responsible for the contraction of the heart, utilizing an intricate network of contractile proteins and iron transporters for this work, with the main purpose of effectively executing the contraction and relaxation cycle. So contract and relax.
A little important.
This is the relatively important thing here. And there's a link to the site to learn more about that if you want to go there too. So the approach developed by the Harvard John A. Paulson School of Engineering and Applied Sciences team first involves using rotary spinning to create thin gelatin fibers. And the process is somewhat akin to the way cotton candy is spun or created, right? You remember seeing a cotton candy machine. It's always fascinating to watch. Luke McQueen, a postdoctoral researcher, involved in the project, had the idea that infusing such fibers into a printable hydrogel ink could help it to maintain its shape after printing. When stimulated using electricity, the structure beats along the orientation of the fibers, giving the researchers plenty of control over its behavior. Oh, so cool. And once printed, the cardiomyocytes within the gel align along the fibers and will beat in that orientation once stimulated using electricity. Oh my goodness. This technique could unlock more advanced cardiac models for drug testing and could also permit personalized medicine for cardiac patients. The implications, once again, of this are so profound. Hooray again for this kind of research. It's just so uplifting in the world of medical technology.
I'm guessing when they're saying the personal medicine, I'm guessing, Ralph, that they would scan your ventricles or whatever's kind of going wonky and be able to get a model of it and kind of play with it and see if, would surgery, would a stitch here, would that. I'm guessing they're able to very personalize and tailor an approach to your ventricle, not just a ventricle.
Exactly. Think about heart valve replacement or ventricle or whatever. And we're all different, right?
Mm-hmm.
Instead of a one size fits all mass produced replacement, you could personalize through 3D printing a ventricle or what have you that's made for me or for you. That's what's so great about this. It just blows my mind. Brilliant research.
Yeah, there's a lot of parts to that story that I had never heard of before, and especially the all the video of like the cotton candy-esque production of this thing is very, very fun to watch. And of course, ladies and gentlemen, if you want to see that, you can see it right there on the screen. Or if you haven't seen that, come out to our website and check that out. So, Ralph, at the end of the show notes that we're going to have posted by the time everyone hears this, please go ahead and mention the honorable mentions.
Yes. I can't resist some of these stories that we don't have time for in our segment, but a few honorable mentions this week. Headline: 3D printed toilet is so slippery that nothing can leave a mark. I've spent a lot of my adult life scrubbing my toilets, right? Mm-hmm. Not because I'm a gross person, but I mean, it's something everybody can relate to.
Toilets can be improved. I believe that wholeheartedly.
Why is this stuck on here? This sentiment, this buildup of mineral or whatever it is, just drives me nuts. There's an article in New Scientist, so you can check this out. This research has come up with a surface treatment for toilets that basically absolutely nothing sticks to this. And how they did it is a real fun story. So check that out. Another headline: Mozart can act as a painkiller for newborns. First of its kind trial suggests. Comes from Science Alert. A really interesting story. Check that out. And the last honorable mention this week, I absolutely love this. You have to see the video and see the images of this solar panel, because think of a solar panel that's shaped like a flower with petals. But imagine this flower can open up and can rotate around to follow the sun for optimal absorption of the energy. It's an outfit that has created a product called Smart Flower, and smartflower.com. We got the links. There's a great YouTube video, shows it in action. I just think applause. It's another creative, fun, and kind of attractive and cool looking thing for solar energy capture. So check that out. That's our final honorable mention for the week.
Absolutely, and really the pictures that I don't know where they get the inspiration for Smart Flower. It's really befuddling where they get joke, obviously, but no, ladies and gentlemen, if you want to find that and more, and of course we have an entire segment at the top of the page dedicated to Ralph, and of course he has his own site where he posts everything, and has even more besides. Ladies and gentlemen, computeramerica.com, and we'll have links to everything. I hope you have a great weekend. Just a reminder to everyone out there, Ralph will be on vacation the next 2 weeks, and the following week we'll have a little out of sync show there for you, and then I'm on vacation that next Friday. So Ralph, we gotta line that up better next time. But no, ladies and gentlemen, always a lot of fun. computeramerica.com. Until next time, have a great day, have a great weekend, do something fun. Bye everyone.